Hello friends, so in today's question, find the acceleration a1, a2 and a3 of the three blocks shown in the figure if the horizontal force of 10 Newton is applied on 2 kg block, 3 kg block and 7 kg block. So this is the figure. So these are 2, 3 and 7 kg, and we have to find out the acceleration a1, a2 and a3 when first force is applied on 2 kg, on the second case on 3 kg, and on the third case when the force 10 Newton is being applied on the 7 kg block. Coefficient of friction between 2 and 3 is 0.2, and between 3 and 7 it is given as 0.3, and between 7 and ground it is frictionless as the coefficient of friction is given as 0. So let us do it for the first case. Force F is applied on 2 kg block. So let us draw the various forces. So this is of 2 kg, this is 3, and this is 7 kg. A force F is being applied on 2 kg and value of F is given as 10 Newton. So this 2 kg will try to force 3 kg towards left. Let us call this as frictional force Fr1. Equal and opposite will be acting here, so this will be also Fr1, and similarly this 3 will try to move 7 kg in the same direction, so let us call this as Fr2, and equal and opposite will be here acting Fr2. These are the various forces other than the normals. So let us assume that all these three blocks move the same acceleration. Okay, say assuming let all blocks 2, 3 and 7 kg move with same acceleration, and which we assume that is given as A. So if they move with same acceleration, so this will be 2 plus 3 plus 7, external force of 10 Newton is being applied on it, and it is moving with the acceleration A. So from here we can find out that our acceleration A will be coming equal to, the force is 10 and divided by 2 plus 3 plus 7, and which will equal to 10 divided by 12, or we can say this will be equal to 5.6 meter per second square. So this will be the acceleration if all the blocks are moving with the acceleration A, or same acceleration. And let us here find out what will be our Fr1, or we can say call it Fr1 max limiting, that will be equal to 2, and the coefficient is given as 0.2, G is 10, so we get this as equal to 4 Newton. And let us find out our Fr2. So Fr2 total weight will be 2 plus 3, coefficient is given as 0.3, and this is 10. So we can say, okay, in this case also this will be limiting Fr2 max, and that will be coming is equal to 15 Newton. So we have value of the two frictions, Fr1 as well as F11, Fr2. Now let us see whether there will be any slipping between 2, 3 and 7. Okay. So we are going to use, let's say, for block 2, for block 2 kg. So this is 2 kg block and applied force is 10 Newton and it is moving with acceleration 5/6, and we have a friction that is Fr1. So in this case we are going to find out value of friction Fr1 and compare it with the maximum value, and then we can decide whether the slipping is going to take place between 2 and 3 or whether it's not going to. So we can write this equation as 10 minus Fr1 will be equal to 2 into 5/6. This will be coming as 5/3. We can solve it. Simply Fr1 will be equal to 10 minus 5/3, and this will be coming equal to as 30 minus 5 divided by 3, which will be equal to 25/3, and this can be right that it will be coming approximately equal to 8.3 newtons. Okay, so if you make comparison between the Fr1 and Fr1 max, okay, you can say comparing Fr1 with Fr1 max, because maximum available friction is 4 Newton, whereas for this acceleration the value of friction is coming as 8.3. So if we make comparison, we can clearly say that our Fr1 is greater than Fr1 max. So under this condition, slipping is going to take place between 2 and 3. You can say slipping is going to take place between 2 kg and 3 kg. So if slipping is going to take place between 2 and 3 kg, now it is clearly understood that they won't be traveling with same acceleration, or rather we can say 2 will not be moving with acceleration 5/6. So from here you can say that 2 kg will not have acceleration which is a and which is equal to 5/6. So let us say that this 2 kg is traveling with acceleration a1. Suppose 2 kg is moving with acceleration, let us call this a2. So we can draw the free body diagram. So this will be 2 kg, a force of 10 Newton, and it is moving with A2, and we have a force of friction that is Fr1. Now as there is a slipping between 2 and 3 kg, this value of Fr1 will be its limiting value. Okay. Because of slipping between 2 kg and 3 kg, you can say Fr1 will be equal to Fr1 max, and which is our 4 Newton. So we can write the equation now. you can say 10 minus FR1 max is equal to A2. From here we can write A2 is 10 minus FR1 max is 4 and divided by 2. So you can say that A2 will be equal to 3 meter per second square. So this is acceleration for 2 kg. Now, as there is slipping between 2 and 3 kg, so 2 will be moving with different acceleration. Now let us check whether there is any slipping between 3 and 7 kg. Okay. So once again, we say let 3 and 7 kg move with same acceleration. Let us call this capital A. So we have this as 3 plus 7 and FR1, and they are moving with acceleration capital A. So we can find out that FR1 is our 4 Newton. So we can say our acceleration A will be equal to 4 divided by 3 plus 7. So we can say A will be equal to 0.4 meter per second square. Now let us find out the value of whether this acceleration will be supported by the friction value. Okay. So let me write it here. So we can say that from here A3 will be 0.4 meter per second square, and also A7 will be 0.4 meter per second square. And now let us verify whether this is feasible or not by finding the value of the friction. So let us consider a 3 kg block. You can say for 3 kg block, so this is 3 kg. This is FR1 whose value is 4, and it is moving with the acceleration of A3 which is 0.4, and let us find out what will be the value of FR2. So we can write the equation as FR1 minus FR2 will be equal to 3 into 0.4. So we get FR2 is equal to, this value is 4, this is 4 minus 1.2, and that will be coming as equal to 3.8 newtons. But the maximum value of FR2 max is 50 Newton. Okay, let me write here. FR2 max is 15 Newton. So if you make comparison, you can clearly say that FR2 is less than FR2 max. Therefore, no slipping between 3 and 7 kg. No slipping between 3 and 7 kg, or we can say they will be moving with same acceleration. Both 3 and 7 kg will move with same acceleration, which is in this case capital A, and which was 0.4 meter per second square. So it means A3 will be equal to 0.4 meter per second square, and A7 will be also 0.4 meter per second square. Now let us do it for when the force is being applied on the 3 kg block. Okay. Let us consider case 2. Force is applied on 3 kg block. Force is applied on 3 kg block. You can draw. So this is 2 kg. This is about 3 kg, and now this will be about 7 kg. Force is being applied on 3 kg, which is of 10 Newton, and so this 3 kg will try to force 2 kg towards left side, and let us suppose the friction is Fr1. Equal and opposite will be acting here, Fr1, and similarly let us call this Fr2, and there will be acting Fr2 here also. So these are the various frictional forces acting on the blocks, and let us assume that they are moving with same acceleration. You can say let all blocks move with same acceleration, which is A. So we can find out value of A. A will be equal to 10 divided by 2 plus 3 plus 7. So from A we can say A will be equal to 5 by 6 meter second square. Now we are one by one going to check whether there is slipping between 2 and 3 and 3 and 7. Okay. So let us consider for block 2. So this is our 2 kg block. Fr1 is being applied on it, and it is moving by 5 by 6 in this direction. Okay. So we find out value of Fr1 and compare it with the maximum value of the friction. You can see our Fr1 will be equal to 2 into 5 by 6, which will equal to 5 by 3, and this is approximately 1.6 Newton. And we already know that Fr1 max we calculated is our 4 Newton, and Fr2 max is our 15 Newton. So if we compare Fr1 with Fr1 max, you can say that Fr1 is less than Fr1 max. So basically it means no slipping between 2 and 3 kg. No slipping between 2 kg and 3 kg. Now let us check for between whether it is slipping between 3 and 7 kg. For this, let us consider the block of 7 kg. So we can say for block 7 kg. So this is our 7 kg. Friction is here Fr2, and it is moving with acceleration of 5 by 6. So we can find out our Fr2. Fr2 will be equal to 7 into 5 by 6, which is equal to 35 by 6. Okay, and this will be coming equal to as 5.8 nearby Newton. Now we know that Fr max is 15 Newton, FR2 max is 15 Newton. So making comparison, we can clearly say that FR2 is less than FR2 max. So it also means no slipping between 3 and 7 kg. So as there is no slip between 2 and 3 as well as 3 and 7, all three blocks will be traveling with the same acceleration. So we can draw a conclusion that all three blocks will move with same acceleration. You can say acceleration of 3 is equal to acceleration of 2 is equal to acceleration of 7, which is given as 5 by 6 meter per second square. And let us consider case 3. And case 3 is that when force is being applied on 7 kg. We have case 3, force F is applied on 7 kg. So let us draw the various forces. So this is 2 kg, 3, and this is over 7 kg. And force is being applied on this. F is equal to 10 Newton. So it will try to make sure that 3 follows 7 and with FR2, and equal and opposite will be acting here, FR2. Similarly 3 will try to move with FR1 and equal and opposite FR1 will be acting here. And in this case also we assume that all three move with same acceleration. Okay, let us say let all blocks move with same acceleration, which is equal to A, and we already calculated, it will be same. A will equal to 10 divided by 2 plus 3 plus 7, so we get A will be equal to 5 by 6 meter per second square. Now let us find out whether this value of acceleration is friction is going to support it or not. Okay. So let us consider a for 2 kg block. For 2 kg block, so we have 2 kg and a friction force of Fr1 is being applied on it, and it is moving with acceleration A, which is given as 5 by 6. So let us find out value of Fr1. So Fr1 will be equal to 2 into 5 by 6, which is equal to 5 by 3, and this will be coming equal to as 1.6 newtons. And we already know value of Fr1 max. Fr1 max is 4 newtons and Fr2 max is of 15 newton. So if you make comparison, we can say Fr1 is less than Fr1 max. So we can say no slipping between 2 kg and 3 kg block. So this is our first part. Okay. So if there is no slipping, 2 and 3 kg will move together. You can say 2 kg and 3 kg will move together. Now, if they are moving together, let us find out what will be the value of the friction, that is FR2. Okay. So if they are moving together, so this will be 2 plus 3, and this here was 7 kg, and force is being applied on it of 10 Newton. We have this as FR2, and here will be also FR2. So we can find out value of FR2. Okay, and they are moving together. Okay. Yeah, 1 second. Yeah. So 2 kg and 3 kg will move together, okay, with acceleration A, which is equal to 5/6. So let us find out what will be a value of FR2 when they are going to move together. So from here we can say that FR2 will be equal to, this is 5 into 5/6, which will be equal to 25/6, and that will be coming approximately equal to 4.1 Newton. Now we are going to compare FR2 with FR2 max. So from here we can say FR2 is less than FR2 max. So under this condition, no slipping between 2 plus 3 and 7. Okay, you can say no slipping between 2 plus 3 and 7 kg. So it basically means they will be moving, they will move with same acceleration, and which is A3 is equal to A2 is equal to A7, and they will be moving with acceleration of 5/6. Yeah, they will be moving with acceleration of 5/6 meter per second square. So this completes the question. Thank you.